This video is the solutions and explanations to the back of the Lewis structure note paper. And so I'm going to draw these Lewis structures with a fairly quick explanation, but some of them are trickier than others. All right, so starting off with CO2. Of course, remember we always do a electron count. So carbon brings me 4, each oxygen brings me 6 for a total of 16 electrons. This is the first time we've encountered the situation where it's more than 2 atoms. Or no, I'm sorry, it's not the first time. We've seen a carbon before. So it's more than 2 atoms, but there is a carbon. So carbon goes in the center. So here's your carbon, and then the oxygens go around the carbon somewhere. I put my valence electrons on. 6 for the oxygens, and 4 for the carbons, and of course then I bond. So I create a bond, and just looking at this, it's pretty obvious that nobody has an octet, and so it's probably time to do some double bonding. So I'm going to take this electron and move them just up here. That's totally legal. I'm going to connect them and form that double bond, and once I do that, I see that this oxygen has 2, 4 to himself, and 4 in the double bond. That's 8. The oxygen's good. But the middle carbon only has 7. 1, 2, 3, 4, 5, 6, 7. Same for this oxygen, only over here only has 7. So I'm going to take this electron and form a double bond there, giving everybody an octet. And of course I want to verify that I have 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. So there's my Lewis structure for CO2. 2 double bonds. Remember, we're always checking for octets for everybody except for hydrogen, who's always satisfied with 2 electrons. Everybody else, we're looking for an octet. CO, a little bit harder. C brings me 4, and oxygen brings me 6, which is 10 electrons. There's only 2 atoms, so they go side by side. 1, 2, 3, 4. 1, 2, 3, 4, 5, and 6. So looking like that. And then I start to bond. So I create my single bond. Nothing is satisfied with the octet. So thought process probably is a double bond. So take this one and form that into a double bond. Now, this is where it gets a little tricky because sometimes students leave it like this. The oxygen has an octet. A double bond and then 4, electrons on oxygen. But the carbon only has 6 electrons. So that's no good. So the thought is, what about triple? So what if I take this and make a triple bond? And we're getting closer, but the oxygen has 1 more electron. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm actually going to pick it up and move it over here to the carbon. And so now everybody has an octet. They're sharing 6 and each have 2. So it was a little tricky, but that is a triple bond. Okay, OH minus 1. It's an ion. Okay, so we have to keep that in mind. Oxygen brings me 6. Plus 1 for hydrogen is 7, but it's a negative ion. It means it's gained an electron. So it doesn't have 7, it actually has 8. And keeping in mind, I'm going to have to add that electron in. So side by side, 1, 2, 3, 4, 5, and 6, and 1 on hydrogen. Whoops, sorry. Here, let me redo that. There we go. 1 on hydrogen. I connect them to form a bond. And hydrogen's good, but oxygen only has 7 electrons. 1, 2, 3, 4, 5, 6, 7. But before we panic, we have to remember we have to bring this extra electron in. It makes sense to put it on the oxygen. And because this is an ion, I need brackets and a minus 1. Okay, again, telling your reader that you have given that an extra electron. Okay, NH4, we actually did on the front. It was 5 plus 4 electrons, which was 9, and I had to subtract 1. Whoops, oh my goodness. Which gives me 8, and it looks like this. And that was your example on the front. Of course, it needs to be in brackets with a plus 1 out to the side. So my apologies for giving you a duplicate. Okay, this one's challenging. SO3 minus 2. So sulfur brings me 6. Each oxygen also brings me 6 for a total of 24. But I can't forget about these. This minus 2 means I've added 2 electrons. So my total is actually 26 and not 24. And those 2 electrons I'm going to have to add in to my picture. I'm physically going to have to add them after I have counted valence. So this is the time where we have to consult this idea of electronegativity, because if I don't have any carbons and I have more than 2 atoms, it's the least electronegative atom who goes in the center. The nice thing is, in this case, we have 1 sulfur and 3 oxygens. Most of the time it works out so that one element who's by himself will go in the center, and then the other 3 will go around it. It's also the least electronegative. So sulfur's in the middle, and the 3 oxygens are going to surround the sulfur somehow. Okay, something like that. Everybody here gets 6 electrons. Okay, so everybody has 6. I connect and form single bonds. Okay, I still can't forget that I owe 2 electrons to this picture. So if we look, I have an oxygen right here who has 1, 2, 3, 4, 5, 6, 7. So that might be a really good place to add in an electron. And then same thing down here, 1, 2, 3, 4, 5, 6, 7 electrons. So might be a really good place to add in an electron there. And now, this one's good, this one's good. Sulfur's got 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got 1 extra. And this oxygen has 1, 2, 3, 4, 5, 6, 7. So sulfur's got 1 too many. Oxygen needs 1. This is one of those times where you can pick it up and put it on the oxygen. And if we check very closely, everybody has an octet. There are 26 electrons. This is where it's very important. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 with brackets and a -2 charge. And there's my picture. We cannot use a double bond here and make my valence electrons work and make my octet work. Okay, so it looks like this, and that one's quite tricky. PBr3, phosphorus brings me 5, plus 3 from each, 3 bromines, each bringing me 7, gives me a total of 26. In this case, P is in the center. The bromines are going to attach to the P. Phosphorus gets 5. Bromines get 7. Getting smart about your dot placement. Okay, and this one works out very nicely. Single bond, single bond, single bond. Whoop. Everybody has an octet. And I have 26 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. No need for brackets and a charge because it's neutral. And so those were my first 6, and I believe we have 5 left to do. So give me 1 second. Okay, so B F4 minus 1, H CO3 minus 1, into H2 C2H4 and H3O plus 1. Okay, so here we go. BF4 minus 1. Boron brings me 3 plus 4 fluorines, each with 7, so that's 28, 29, 30, 31, plus 1 electron. Remember, the negative means we've added an electron, so again, I'm physically going to have to add that electron into my picture. And boron's in the center. 4 fluorines around. 7 electrons on each fluorine. And 1, 2, 3 electrons on bromine. Okay, it looks like I can't bond that last fluorine until I remember I have to add an extra electron. Great place to do it would be on the boron. Connect that and form a single bond. It's got 32 electrons, and everybody has an octet. So that is BF4 -1, except I still need brackets. And a -1 charge to make this known as an ion. HCO3-, they gave you a little hint. It said carbon's your central atom, and the H is connected to an O. So knowing that, well, let me do my electron count. 1 from hydrogen, 4 from carbon, 3 oxygens, each with 6. That's 23 plus 1. So 24 electrons. So carbon's a central atom. And it says the H is connected to an O. So that must mean O, 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 and then an H kind of on the end somewhere. So here we go. Okay, 6 on the O's, 4 on the carbon, 1 on the hydrogen. We connect everything with single bonds to start. Single bond, single bond, single bond, single bond. Good with 2 electrons, good with 8 electrons, but this is a mess over here. I still have 1 to add. Okay, don't forget about that 1 to add. I'll add it right here. Makes this guy good. 2, 4, 6, 8. It's just this O and this carbon here. They don't have an octet. Leads me to think it might be a double bond. Let's take this guy and this guy, move them, and double bond that, and then check it out. 2, 4, 6, 8. Carbon's got 2, 4, 6, 8. 24 in my picture. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There it is. Missing brackets though, so I need to add those brackets in with a -1. Into H2, we talked about that the H's can never be in the middle, so the N's are going to have to kind of share the middle, since it's a little bit different, and the H's are going to connect to the nitrogens. 2 nitrogens, each bringing me 5, plus 2 hydrogens gives me a total of 12 electrons. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1 and 1, single, single, single. H's are good, N's are not. These single electrons down here are screaming at me to double bond them. And 2, 4, 6, 8, 2, 4, 6, 8, there it is. 2, 4, 6, 8, 10, 12 electrons total in my picture. No brackets needed for this one. C2H4, kind of a similar situation. Carbon brings me 4 apiece, so that's 8 total plus 4. 12 electrons in my picture. Carbons are going to share the middle spot, and the H's are going to attach to the carbons, so something kind of like this. Okay, carbon's going to bring me 1, 2, 3, 4. 1, 2, 3, 4. So, oh, I forgot my electrons on the H's. So bond, 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 bond. We notice that those carbons do not have a octet, so again those single electrons are kind of screaming to double bond, and so this is a double bonded carbon. 12 electrons total. 2, 4, 6, 8, 10, and 12. Notice every single one of those electrons is shared in this case. They're all bonded. Okay. And last but not least, H3O+, 3 from the hydrogens. Plus 6 from the oxygen is 9, and that +1 means it's lost 1, so it should have 8 O's in the middle, 3 H's surrounding, 1, 2, 3, 4, 5, 6, 1, 1, and 1, bond, bond, and bond. But remember, I physically need to remove an electron. Right now the O's got too many. Here, this looks confusing. There we go. Right now the O's got too many, 2, 4, 6, 8, and there's that 9th one, and that's the one I would like to remove. Now it's got 8 for O. All the hydrogens have 2 and 8 total in my picture. Missing brackets with a +1, and there's your Lewis structure for H3O+.